Chicago Inventors Organization welcomes the opportunity and challenge to convince donors and corporate funding entities that together we can create a Chicago that excels in the development of innovative products by underserved vendors. We are at a critical pivot point in America as to how we must create generational wealth to wipe out the poverty which exists among over 11 million Americans today. As a 501c3 nonprofit organization, we ask you to join us in our Creating Next Wave Inventor Entrepreneurs movement. We challenge you to help us create new products and new businesses. Your sponsorships and donations will help us to enhance our Next Wave Inventors Academy and 3D Next Wave prototyping lab operations. Our Academy seminars focus on educating inventors on smart technology products, patents and trademarks, prototyping, marketing and pricing, pitching to buyers and investors, and negotiating contracts. Our prototyping lab provides hands-on support to independent inventors by using computer-assisted designs and 3D printed prototypes to make their products come alive. Your tax-deductible sponsorships and donations will help expand CIO resources to provide enhanced interactive working spaces for multi-generational inventors and purchase the necessary equipment to broadcast inventor classes and events to our network of innovators and the general public.
Hi guys, welcome. Good afternoon, everyone. Can everyone hear me? I know you guys are all muted. Okay, we are going to ask that you guys stay muted for this conference to allow our guests, our panelists, and our other hosts, Calvin and Dennis, to leave your mics off so we can allow you guys to speak. But I wanted to welcome you guys to our annual CIO 2022 Prototyping and Manufacturing Conference. We have a great agenda set up for you guys for today. But before we hop into it, I did want to go over some housekeeping rules, but I'm just looking at the faces here because, we don't get to see you guys so often. So it's good to see you guys' faces. Good deal. I see all my panelists are here as well. Welcome, guys. But I wanted to go over a few housekeeping rules for our conference today. Again, we're going to ask that your sound, that you stay muted. So keep your sound off to allow our panelists and our other hosts to have the floor as they speak. We will probably shut your video off as well so that our panelists can have a spotlight for the topics of discussion for today. And then we're also going to ask that you guys hold your questions until the end. You can put them in a chat, but we will have breakout sessions so you guys can ask specific questions pertaining to your specific invention idea to our guru panelists once we have those breakout sessions. And yeah, we're just gonna have a really good time today. We're gonna learn a lot about manufacturing and prototyping. We even have Kenny here as our attorney for those of you who have legal questions. He is your legal guru. He is our go-to guy when it comes to legal matters dealing with your invention. So Calvin, I'm going to go ahead and pass it over to you to give us a great welcome.
You funny. Well, anyway, welcome. Welcome to the Chicago Inventors second Inventors Conference of the year. And I just want to welcome you guys. My name is Calvin Flowers. I'm the president of the Chicago Inventors Organization. And our organization, we are a nonprofit organization, and we are committed to helping inventors navigate the invention process. When I say navigate it, it doesn't matter where you are in the process, more than likely we will be able to help you. And we do that in several ways. We educate aspiring inventors and entrepreneurs on the navigation process via our, what we call this Inventor Academy, which is classes that we hold every Tuesday night virtually at 6 o'clock Central Standard Time. And we also help inventors develop their concept, their ideas into quality marketable products. We do that with our volunteer lab team. We have a 3D printing lab here that we plan on expanding. But right now we have 4 3D printers and we're looking pretty good here. And we do help protect your ideas. We are affiliated with a pro bono patent program and also some pro bono legal services that we will be able to offer you from time to time. And also we help inventors mass produce their products. We have a growing network of manufacturers. One of our main manufacturers is going to be the speaker here, one of the panelists here, CMS World Sport. We've been working with them for years now. I don't even know how many years it is. And then we help inventors launch their products. We have conferences where we introduce inventors to buyers, licensing folks. And we also have a pitch contest that's coming up in the fall. So those of you that don't have your elevator pitch together, start practicing because that's coming up real soon. And also in the very near future, we are going to launch what we call as an inventor e-commerce platform. This platform is going to help inventors start getting sales for their products before they get to that big buyer. So with that being said, now, some of you probably already know that I'm an inventor myself, and I was fortunate enough to sell my product nationwide at Walgreens. But along the way, I ran into every brick wall you can imagine. I fell in every pothole. I raised a ton of money, messed up a whole bunch of money, but somehow I figured it out. But I had to do it on my own because there was no inventors organization around in Chicago to help me figure that out. And when I say I had a lot of problems, one of the problems was I didn't know how to find a manufacturer. I didn't know how to, what to expect from a manufacturer. And the prototype I was working with, it was handmade. I didn't know how to get that refined into an engineered prototype. And so it was very difficult. So we thought that this conference today would be a really good resource for you inventors that's trying to, get your prototypes done, or maybe you're trying to find a manufacturer. And so with that said, I'm gonna turn this over to our moderator, David Girzadas. Now, David is a fantastic person, really, really knowledgeable, and he has done a lot of things. Matter of fact, he's doing a lot of things right now. And we met David maybe a year or so right before the pandemic, and we identified a lot of things that we had in common. We were beginning to collaborate on how we could work together, and then came the pandemic. So David, I hope that we can pick up where we left off. But in the meantime, before I introduce you, I want to read your bio. Now, David is the Dean of Engineering and Advanced Manufacturing at Richard J. Daley College, and came to Chicago City College from a successful career as an engineer in manufacturing operations. David, he worked for 26 years building locomotives for General Motors in their motor electromotive division as a quality manager. He's known as a problem solver, and he's well educated. He received his bachelor's in mechanical engineering technology from Purdue, and he got a master's degree in manufacturing engineering from Northwestern, and then he got another master's degree in business management from Northwestern. So with no further ado, David, I want to turn this over to you. We do really appreciate you sharing your knowledge and your skills, and we appreciate you moderating this conference.
Thank you, Calvin. Thank you for that very kind intro. I'm really looking forward to this panel. I think we have a great group of people on the panel. The last time we did this, I think it was a couple of years ago, I learned a lot from the panel. And so, you know, without further ado, let's get going. Let's get into the panel. And, you know, towards the end, we could have questions and answers, but I think we'll learn a lot from the panel today. And then I'll try to bring up some questions for the different panel members as we go and hear from them and learn about their background, their experiences in prototyping and manufacturing and ideation. And we'll try to have this a little bit of a learning session on some of the buzzwords within these processes. How does that sound, Calvin?
That is perfect, man. I'm excited to hear about it, and I'm quite sure these inventors are waiting to hear from you sharing your expertise.
Very good. All right, so panel, do you want to turn on your cameras and open up your microphones? And, you know, I'll go down the list of panelists and ask you to introduce yourself, what company you're from, and then just a little bit about your background in terms of your background with prototyping and manufacturing and what brings you to the table today. So I see Ray, Mattison, Mattison. Let's start with you.
Hi, Mattison is good, kind of like Wisconsin. I'm Ray Mattison. I started Design IQ about 10 years ago. Design IQ is a transportation and product design studio, and we generally work in the early phase development of products, generally with starting off with aerospace products. We worked on aircraft like the Cirrus jet, some products for Cessna and Eclipse jet. In the past 2 or 3 years, we've been really expanding our scope to work with electronics projects like Bluetooth speakers, and also the automotive realm, working with off-road Jeeps and sports cars and things like that, really leveraging our understanding of carbon fiber composite materials and working with you know, aerodynamicists and structures engineers, and really optimizing what they learn to make a vehicle perform better. So that's Design IQ in a nutshell. And that's how long we've been doing it.
Very good. Thank you, Ray. Mark Dyser, welcome.
Hi. Well, that's a tough act to follow. Ray, it sounds like you are pretty amazing work that you're doing there. My name is Mark Dyser. I represent Surge Creates, and we are the creators and inventors of everything from Burger King toys, kids toys, to small electronics, and everything in between. So there's an exciting array of different types of work we get involved in. I'm originally a graduate from the Ohio State University in industrial design. Been designing probably for over 25 years now, going on 30 years. And I've touched everything from graphic design to package design, product design, and more recently, probably within the last 10 years, we're even getting involved in digital, what we call transcendence, digital design of creating physical products that interact with the digital world. So we produce millions and millions of toys annually through kids meal programs, and we understand that those have the highest safety standards in the industry. So we're very well versed in safety regulations, material selections, and understanding how to take a product from idea to manufacturing. So that's it in a nutshell.
Very good. Thank you. Noah.
Hi. So it says McNeely on the screen. It's actually McNeely, but not a big deal. There's actually, if you Google me, there's one other Noah McNeely, but he's a high school kid somewhere, so not the same person. I've been developing product for about 25 years. Educationally, I am a graduate of Georgia Tech. My first degree is mechanical engineering, and on that side of product development, I make things work, I make things manufacturable, I make sure things are durable and cost what they need to cost. My graduate degree, also from Georgia Tech, is in the field of industrial design. And within that space, I deal with all the human side stuff related to product development. So ergonomics, aesthetics, human factors, usability, intuitive, all the stuff that makes a person want to use a product. To keep it short, first 15 years or so of my career, I built a different company with some other partners. We did all sorts of product development contract work for very large companies like Black & Decker and Home Depot and Coca-Cola and Procter & Gamble. Most people have encountered a product I helped bring to the market at some point in that experience, though I'm getting a little further from it now, so I'm not sure that's still true when I talk to younger people. Grew that company to about 40 people. I ran that company as the CEO for about 5 years. Reached what my wife calls my midlife crisis about 10 years ago. I realized that I really enjoy working with entrepreneurs and startups, and I really didn't like managing 40 people. So I wasn't doing any of the fun stuff anymore. So long story short, sold that company to some of the employees. They're still out there. We're still friends. And that's how Product Quickstar, which is my current company, was born. Very intentionally, I focus on entrepreneurs and startups and early stage companies. And I and my colleagues, we do everything related to making stuff. So pencil to paper design, engineering, full industrial design, prototype development of all different types, all the way up to helping my clients find factories, audit those factories, make sure those factories are going to do a good job for them, really all the way up through getting that first order of product, into the warehouse. And what I tell people is I can help you make anything, help you fill a warehouse full of product. I can't help you sell it. I can't help you market it. I don't do any of that stuff. I stay in my lane, which is really developing and making things.
Very good, very good, very interesting. And on our panel, we have two people from the same company, Austin and Rachel.
Hi, David. Well, thank you for the introduction, and definitely sounds like you guys have a great expert panel there. So we'll kind of, dive into who we are and what we do. My name is Austin Reeves here at CMS World Group. Across from me is Rachel Rooney from the same company. We're both project managers as well as VPs in different categories. I work a lot with the newer inventors, and Rachel does a lot more on the manufacturing side, but of course we work as a team here. But a little bit about CMS. We've been around for 30 or so plus years. This is our office here in Clearwater, Florida. CMS is a conglomerate of 18 factories. All of our factories are overseas. We got a couple in Pakistan, a couple in Taiwan, but most of our operations for advanced prototyping and mass manufacturing is done at our Chinese plants, ranging south from Hong Kong up to Shanghai. We do have our other office in Shenzhen that's ran by our director of CMS China operations over there. But primarily, we are a manufacturing core, making thousands of different types of products, ranging from cut and sew, injection plastics, metal fabrications, tons and tons of electronics that we've been getting into over the years. But besides our manufacturing capabilities, we're also a development house. So we have a great engineering staff, great designer, mechanical engineer, 2 electronic engineers. So all the design work, the design and development is done in-house with our engineers. You're able to come meet with us face-to-face, get a tour of our showrooms, meet with engineers in person, go over your project. We'll go through the development of it. We do a lot of engineering, CAD designs, 3D engineering, followed by prototyping. And once you're satisfied with the prototype, and at that point in time you want to move forward to manufacturing, we can easily transition you from the prototyping, design development side of things into manufacturing. We do all the packaging, producing it, and ship it to any one location that you desire. So we hope to work with many new inventors and get a lot more products made for you.
Very good. Thank you. Thank you for that intro, everybody. So let's go through this in a couple of big chunks of steps or milestones in the product development process. Let's start with ideation and some of the concerns, some of the things that people should be thinking about very early on before they ever start to make that first product. And I'm just going to suggest, Noah, do you want to start with that?
Oh, he's on mute.
Sorry about that. I muted myself. Okay, can you hear me now?
Yes.
All right, so you wanted me to start with very early on, I
Very
guess.
early on, things that an inventor should think about prior to making anything about product design, ideation, how do they know it's a good idea, et cetera, before they start going out there.
Well,
Yeah.
first off, don't trust your mom and your friends. You know, they're all going to tell you have a great idea. So, you know, I meet a lot of inventors come in my door, and they're all at different levels. Some just have an idea on paper. Some have done a lot of work in the garage or whatever. Some have taken it quite a bit further. You know, they've gone out to Upwork. They've hired an engineer that kind of halfway knew what they were doing to get them so far. My advice to everyone I meet is don't hire me, don't pay me or anyone else to do stuff you can do on your own. In fact, I meet a lot of people and I give them homework and say, you know, look, you spent 20 minutes telling me about what you're trying to do. Here's the problems I see with it from whatever standpoint it is. You know, sometimes I don't see problems and we can jump into quoting out a project, but a lot of times I find there's some issues. So I give them homework, go away, see if you can solve these issues, and then come back and we'll work together, because I stay busy enough. I don't need to finagle anyone to do work with me just because I need them to do work with me. I'd rather only work with people that I see have a path forward. So there are a lot of people, as everyone on this panel knows, that are probably out there that are gladly just take your money to work on your project. But my advice to you is try to get as much honest advice as you can from people that will give it to you, and try to do as much on your own before you start writing checks to people like me or patent attorneys or anyone else, because then you will know more about what you're trying to accomplish by having tried to do some of it yourself, and you'll be better in a better space to use your hired resources more efficiently.
Very good. Makes a lot of sense. Ray, looked like you were, or Mark, looked like you were nodding your head, had some thoughts along the same lines.
Yeah, I mean, that's right on track to basically how we work. And I always work on a personal level with any inventor is first, we just want to establish a need. And, you know, this is my personal philosophy in design and inventing is there's a difference between inventors and artists. And, you know, artists really do stuff to make things look beautiful for themselves and they sell it. But as designers and inventors, we make stuff for other people. So one of the things I like to have a conversation with the inventors for is make sure that the product that you're making has a need and a purpose, and that it has substance, and it will survive if it does. It will carry itself. That marketing part and that selling part we don't do, but if you have a great product, a lot of times it will sell itself. So just do your homework, like Noah said, just do your homework. Come to us when you're ready with information and questions. And we love to answer questions. So bring a list, write down notes, and bring a list of questions that you may have with regards to your product, and don't come in blind. It's really.
Are you expecting a blueprint? Are you expecting a blueprint at that time, at that first meeting?
Not at all.
Yeah.
But we do like to have conversations that the client knows the market well, knows where this would fit in the market, who it's being sold to, and kind of have a little bit of background on what that user is or who's going to use this and who's this intended for. So we like to have that foundation first with any inventor that we work with.
Okay, great. Ray, any thoughts?
Yeah, you know, having worked with mostly capital intensive projects, being transportation projects, they sort of run into the same problems that I think a lot of the smaller projects run into. And like you said, the project market fit is probably the most important part of, you know, why to launch a product, right? Is it, you know, is there a customer for your product? So of course, that's the first thing that that you need to look at. One of the things that I think inventors sometimes aren't prepared for, having not gone through that validation process, is how intensive the tooling and having the hired guns on, how expensive that process can be. So early on, I really do think there is a lot of homework, just to back up what Noah said, in validating your idea and getting it out there, even if it's a 3D printed prototype, and getting it in as many hands as you can, that, so that you can make sure that it is something that's worth chasing. Because once you start down the path of paying the hired guns and getting the tooling done and getting the the engineering done, it's a fairly long and intense process. Quite a lot of times, a lot longer and more intense than I think a lot of inventors are aware of.
Yeah, Ray, you had mentioned working with high-tech products in terms of sensors and electronics and things like that. At this point, if somebody's product idea involves some automation or sensors or electronics like that, what level of understanding do you expect them to have coming to you for that first time? How the product works in general without the details?
Yeah. Usually you should have a technical person on hand. We're an industrial design house, so we don't do a lot of like what CMS talked about with the electronics design. What I think is probably more important than having that technical expertise and, let's say, programming is to understand what that user experience should be. And having a real storyboard for the programmers to be able to follow. A lot of times I think there's a disconnect as me approaching it as an industrial designer from an art standpoint, and I like to think of myself as the what, talking to the engineering, which I think is, I've typically approached them as the how. You really do need to tell a very concise and complete story about what you expect the product to do. And I think that, having storyboarded that, or workflow that user experience, I think that makes it a lot easier for your engineering or your user interface people to give the product the behavior that the customer is expecting.
Got it.
And I think there's a lot of industrial design techniques that you can use to sort of prototype that user experience before starting the very intense electronic engineering process.
Okay, very good, very good. All right, CMS World Group, let's start to move this discussion more towards the prototyping and those first few examples and workable products and leading up to that. Let's bring some explanation to that for
absolutely. And I was touching on that previous question about coming to the product viability. One aspect we always tell customers too is use that tool out there called Google, right? A lot of people think they'll come up with something, no idea, but then they don't really like what Noah said or some of the panels, do their research or their background checking to see what products out there. Before a customer wastes their time, it's always good just to jump on there and see, it's on Amazon right now for $4.99. What makes your product different? What sets it apart from the competition? So on and so forth. So when somebody introduces the product to us, we usually look at it two ways. First, is it within our capabilities? Is it within our design and development wheelhouse and manufacturing? Usually the answer is yes. And then second, we think, does it have legs? We've been around the market quite a bit, and so has our other partners in the company, to realize, some of the viability in a product. But at the end of the day, even if we all agree that this, may not be the best, sellable product, who are we to say, right? I mean, look at the pet rock. A lot of times it depends on the marketability, right? You could have the best, hottest product in the world, but if you don't know how to pick up the phone and make a call or send out the emails or get in touch with the buyers, it's not going to ever get launched, right? Versus other products out there that people out there pounding the doors, hitting the pavement, and they're selling hundreds of thousands a year. That's kind of, obviously for new products. But if somebody comes to us too, we get them an NDA, some non-disclosure agreement. That way they kind of get the warm and fuzzies and want to share the product idea with us. So once they share the product idea, either via email, we have a Zoom conference, they come out and meet with us. We'll discuss the product with the engineers. And then we put together what we call a letter of engagement. That's nothing more than a development plan. The letter of engagement's got research, investigation, what materials are out there, what components, why reinvent the wheel? If there's other components and other things we can use, To save you on molding and tooling cost, we will. If there's certain fabrics that we think that'll be best suited for that product or that type of plastic, right? Was it a hard plastic in ABS? Is maybe more of a soft pliable plastic? So that research investigation is very important, it continues on. Then we dive into the actual design and development. That's where we actually create the CAD drawings, the 2D engineering drawings, as well as the 3D engineering. Anything and everything we do for our customers and clients is theirs and theirs 100%. So all the IP remains with the client. We help come up with any designs, a logo, anything, again, that remains with the client. So after design and development, then we move into the prototyping stage. It's also very important to note that during that design and development, the clients are very involved, right? It's not, you know, here you go, CMS, you're retained. I'll look forward to hear from you in 6 months from now. You know, it's not the case. We're very involved with the clients. We're always available via email, via phone. When we send you specs, you have every chance to look at it, review it, ask questions, request changes. We'll amend the specs, resubmit them to you. Once we have your approval, then we go into actual prototyping. If it's something relatively small scale, we do have some 3D printing availability here domestically. Kind of like Calvin was saying, he's got some of those 3D printers there. Again, just for really kind of simple proof of concept, so on and so forth. But over at our Chinese plants, we have, you know, the $250,000 CNC machines and the 3D printers that can really pump out some high-end prototypes, even prototypes that have electronics in them, such as this tooth box here, that we're able to actually incorporate, make basic circuit boards, basic electronics in order to achieve that prototype. Of course, we make the prototype, we get it in, we just spend a day or two with it, then we send it on to our customer for their review and their testing. At that point, once CMS has made a prototype, then we know what the cost of the unit is, right? That's usually the million-dollar question. What does it cost to produce my product? A lot of people want to ask that during the first meeting, and we all have the same answer. You know, heck if I know, right? We can kind of come pretty close, but until it's made, we know the exact materials, the amount of materials used, the type of, you know, how much labor is involved, packaging, so on and so forth. And then we can quote, you know, we know the size of the product. We can know how much the packaging is going to take up, how many we can fit in a container. So we can quote you to the penny delivered cost of your goods. So prototyping is very important in many aspects. Obviously, it's first and foremost, it's a proof of concept, you know, from a development side of the point of view, but it's also from a manufacturing point of view, it prepares us in order to take that next step and go into molding and tooling if needed, or go right into manufacturing with the product.
Very good, very good. Noah, let's add some more to that concepts of prototyping and things that the new inventor should be thinking about, looking out for, asking the people they're working with.
Yeah, so I want to build on what CMS guys just said. I think you know, there are different levels of prototyping. Prototyping serves a lot of different functions. I think a lot of entrepreneurs that have never done the process before, which is fine, don't understand, which is fine because you wouldn't expect them to since they've never done it before. They think a prototype is just a representation of the finished product. And that's true, that is a type of prototype. However, prototyping is actually a very integral and important part of the product development process. I like to think of prototyping as it's a way to learn things we don't know. So let's say we're doing this new widget, it's got these mechanical linkages and gears and all this sort of stuff in there. And yeah, we've done the math. Theoretically, all the physics and the engineering works, but frankly, until you build one, you don't know what you don't know. So we'll start as inexpensively as possible. Frankly, we may machine stuff out of wood. We may do some 3D printing. We may, just depending on what it is, sometimes we do have to do more sophisticated machining, like out of aluminum or steel or whatever, to learn these things. But we like to start at the top of the funnel when we know the least. We like to learn as much as we can, spending as little money as possible. So we'll buy stuff at Home Depot, we'll rig it up, we'll say, oh, well, the physics seem to work. So then we'll go to a more sophisticated level of prototyping, and all the way down until we've eliminated those unknowns by the time you get to the point where you're making what I like to call a trade show prototype or a factory prototype, most of those unknowns should be pretty well eliminated. You should be down to the point of, oh, is it a little too tight, a little too soft? Is it a little too purple? Is it a little too big, a little too small? Just minor tweaks at that point. If you start up here with those real expensive prototypes, you're generally just wasting money because you're going to learn a lot from that real expensive prototype. But you're also, the main thing you're going to learn is I just wasted $4,000 making a real expensive prototype to learn something I could have made with $50 worth of plywood. So prototyping means a lot of different things. You prototype the physics, you prototype the concept, you ultimately prototype the full product. You might prototype the packaging along the way, just see, is it going to fit on the shelf like I think it's going to fit? You might, anything that you don't know, you can use, well, almost anything you don't know, you can probably use some sort of prototype to learn something about it. And that's how we look at it as part of our process.
Thank you. Thank you. That's very interesting. And Mark, and I think what Noah is saying is that there's multiple prototypes, not just one. In your experience, how many, like what's the range if somebody's going to come up with something? Is it 1 or is it 100 or 10 or what's kind of normal numbers for prototypes that you would expect? Not of the same thing, but iterations and improvements.
That all depends on the client.
Yeah.
We've done some projects with Pixar that we've done something as simple as, you know, doing a Woody toy, and you wouldn't believe how many revisions and prototypes we had to go through to make it. And I was really part of what's been great about since I've started designing is being part of working with sculptors and the 2-ups and the different sizes that you work with and the different types of prototypes. We're working with clay, and then we moved into a software called Freeform, which was 3D haptic. So you could actually sculpt your product in the digital environment and feel it in midair with your wand, which was really amazing. But the one thing I want to stress too is that, you know, the goal, and I think Noah's hitting on this, that you want to learn as much as you can for as little as money as possible. And part of those avenues, don't be afraid to shy away from learning a lot digitally. So you can render something up and sculpt something in a 3D environment and not have to really worry about printing it physically to learn a lot about it. You can even now, with the technology that's out there right now, is you could have such a beautiful looking thing. People think it's real. So you learn about how light hits it, how the shape's working. You can do size and testing all digitally. And this is really out there in blue sky world. Eventually it's going to be in a virtual world where you can actually touch with Oculus. You could go in and go into a model shop with your designer and never have to physically ever make anything, and it will be digital. So that's crazy down the road stuff, but that's where prototyping can go. And don't shy away from learning a lot in the digital realm too, as much as physical.
Okay. And then Ray, so the prototyping, we're maybe not using our final materials up front, or maybe not using the final manufacturing process right up front. Do you want to talk a little bit about that and how that changes over time?
Yeah, I would like to. I've got actually my book next to me, The Measure of Man and Woman by Henry Dreyfuss and Associates, as, you know, our ergonomic standard. I think if you're going to do anything that interacts with people, it's a great standard to start with, and it gives you kind of the rules of thumb of, you know, the shape of a person and how a person should, you know, fit in an environment. It has desks and how the level of pressure that a push button should have for an elderly person. It answers all of those questions. But one of the things that I think you'll find out in prototyping is that it's almost always wrong. And a CAD model will almost never come out the size that you think it should, right? It just, you know, when you print it out, it's totally wrong. But the good thing is starting with that baseline and coming up with, like what you said, Noah, very inexpensive mock-ups that are very fast, very easy to change. It helps you from making, it saves you from making, you know, a $100,000 mistake in tooling a, you know, aircraft fuselage, for example, that doesn't fit people on the inside of it. That is one mistake that we actually have made. I wouldn't call it a mistake, but we actually were going down a path of using historical norms to develop the inside of an aircraft interior, and found out it completely did not fit people. And we're able to figure that out using basically the pink foam from Menards, cutting out 2-dimensional profiles at every 6-inch increment. And we built an entire interior of an aircraft that people could actually sit in and see that, this sizing is wrong. And we were able to take rasps and blades and all sorts of, really primitive caveman tools and carve the interior out to what we thought it should be, digitize that, and then, come up with something that we thought was very successful. The customers really, really enjoyed. One of the most important parts of that prototyping process that I think might be one of the reasons why we're fairly successful at what we do is we actually have sort of a digital, we call them digital twins. We'll build each of those cabin cross sections at a known position, fuselage station, at a known position from the origin point, so that when we make a change, we can actually drive that physical change back into the digital representation of the interior, so that we know that, whatever you're looking at in CAD, which is going to give you the wrong impression, is perfectly represented in the real world.
I'll throw this out to whoever wants to answer. What would be an expectation for a length of time for prototyping, and just some cost numbers for somebody just starting out, first pieces, things like that? And I know it's wide range, varies on customers. Yeah, but we're just starting out, and I've got we've got a simple idea, let's say.
Somewhere between a day and a year, and between $1 and $1 million.
All right, we tried, right?
Yeah, it depends on what the product is. I mean, last week I had a guy with a little plastic widget. He came in here and I mocked something up for him on a 3D printer. It took overnight, and then he had it and he was happy with it and ready to go. I've got another project I'm working on right now that's got like 15 different moving components that all interact with each other. We've been working on that prototype for about 3 months now, because we keep learning things, we modify it, we learn things, we modify it. So that's a few $1,000s of materials in that particular case. But earlier in my career, when I did stuff for very large companies, I did this big fairing for Freightliner, and it was tens of thousands of dollars to get that prototype. So there's really not a good answer. It's very situational.
And kind of to build on that, as far as, we always like having the client, it's not necessary, but obviously if the client can bring us, some kind of mock-up prototype, that's ideal. Obviously it goes back to the homework, point of view of it. The more work the client's done on their end, usually the more savings is going to be in their pocket, right? The less money they're going to have to spend, pretty much any designer or any development company. If you come to us with just kind of a chicken scratch, or just not even trying to explain it verbally, all right, we might not get the full grasp of it at that point in time. It's going to take more hours of engineering, or got to go through concepts first and then some engineering. But if you come to us, even if it's got duct tape and you made in your garage, a lot of people sometimes like, oh, it's so ugly, this and that. But we smile from ear to ear, because it gives us a visual. It gives us a starting point. And then back to dollars and cents. The more you've done, the more we can sit there and visualize it and see where you are now and where you want to go with it. The less time we have to spend on the product, which of course translates to dollars and savings. And to Noah's point, behind me here, we have all kinds of array of different products. It greatly depends on the product, right? If it's coming with a cut and sew apparel type of products, the development and the development cost and the timeline is going to be different than, say, a steam bowl that's got electronics, heating elements, power to it. Usually it's pretty easy to think of the higher end components that's got moving parts, electronics, usually going to be more costly than your stagnant type of products. But again, it greatly depends on where you're at with the development process. If you've done engineering with another company and you just need prototyping, if you need engineering from us. But just like a lot of development companies, we can take you pretty much wherever stage you're at and get you to that manufacturer ready state.
Very good. Very good. Thank you. So prototyping, now we've got a product that's been prototyped. We think we could sell it. We want to go into manufacturing. Let's talk about that phase in the process and moving it to manufacturing and considerations for that and deciding on manufacturing processes, domestic versus international, et cetera, things like that.
Yeah, so 9 times out of 10, an inventor will come to us and they think they're ready to move into mass manufacturing, and they really are not. They only have a homemade prototype. They don't have any kind of mechanical specs or CAD drawings or anything. So we kind of have to kind of go through the process with them and get them to that stage. I mean, it's obviously depending on the product. Like if you have a cut and sew product, you don't really need CAD drawings, mechanical specs, more like flat patterns or something. But to get them to that stage, to get them to manufacture ready, we have a process that we go through. But then we also, once you're ready to go into manufacturing, we make production approval samples so that they can get what the product would look like for production, exactly as it would. It would come fully packaged as it would if for when you're getting it delivered to your door.
Yeah, and that's very important if you manufacture with us or any manufacturer in the world, regardless if it's domestic, overseas, wherever, is to have that production approval sample. Don't really place an order and then just hope that all 1,000 units come out based off a prototype sample you saw. You make sure it's made with the correct materials, dimensions, all the spelling is correct on the packaging, the whole 9 yards. You look at it, you test it, and you say, yeah, get green light. You have our okay to go into manufacturing. So now we're manufacturing.
Yeah.
Mm-hmm. So is the inventor coming to your plant to see that? Or are you sending it to them, or a combination?
The production approval sample gets sent to the customer so that they can totally look it over, all the packaging, make sure there's no spelling typos or anything.
Mm-hmm.
Look at the sample, test the sample, and we don't go into mass manufacturing until they give us that approval of that sample.
Mm-hmm.
But you talked about domestic versus overseas. You'll see there's a very drastic cost difference. Getting something manufactured here in the States is going to be a lot more expensive. Same with molding and tooling and stuff. Even 3D printing, we've had looked at quite a few companies that are local to this area, because there are some customers that need something very high quality 3D printed quickly. And most of them didn't even get back to us, and it's been a month and they still haven't gotten back to us with quoting for just to get a sample made or something 3D printed. So it's not only costly, but it's more timely, we found, because we have the ownership of our factory, so we have the control over them.
Mm-hmm.
So we're able to get things done as we want them and get them done quickly.
Very good.
Great quality control in all of our factories. That's the same set forth in all of them. But then once the goods are made, they're shipped over. All the products that we produce are 100% guaranteed. And again, this is, I know it's kind of talking about CMS, but it's in general, any manufacturer you use, you want to make sure you have, some guarantees in place, that your product's insured from the time it leaves the factory, on the water, in the truck delivery, all the way until it's delivered to your warehouse. Just again, doing your due diligence and making sure that you have all your ducks in a row, and that you choose the company that's right for you.
Very good. Noah, continuing with the concept of moving towards manufacturing, issues that come to mind for you.
Sure. So I think to build off what CMS just said, I think working with factories and vendors that you trust or that have been vetted and audited, which is a big part of what I do. I've been doing this, like I said, for 25 years, and I've made relationships with lots of vendor groups and factories over the years. I actually sent CMS a private chat saying, hey, let's connect after this. I'd love to hear more about what you guys do. So it's important to work with factories that you can trust and that you have vetted and that you have that relationship with, because there are a lot of bad factories out there. There's factories, especially, well, anywhere, but in Asia, because frankly, that's where most of our consumer products come from. They come in all different shapes and sizes. I've been in factories that had 6 employees and cats and dogs running around. And frankly, there is a place and a reason for that factory to exist for certain types of products. Probably not most of the products that you want to produce. I've been through factories that have 2,000 and 3,000 employees, like the factory that makes the Roomba robots. So there's all different kinds of factories. Finding that right fit for the client's project is important. If you go to a factory that's used to doing $100,000 order or 100,000 piece orders, and you're trying to do a pilot run of 1,000 pieces, you're not going to get the best service or the best price. Likewise, if you go to a factory that, to do it, that really thrives on those small orders, you have to make sure they can grow with you if your plan is to stick with them long term. A lot of times people ask me, are they going to steal my idea? Am I going to get good quality? And all these things are things to be concerned about. That's why it's important to work with groups that you at least, either you or someone like me or someone like CMS has taken the time to qualify and vet to the point where they're going to do what you need to do. I like to work with factories that do have some engineering people on staff because, frankly, I think everyone in this call, we can design it the best we can, but until it starts coming out of the molding machine or the forge or wherever it's coming out of, things are going to change. Things are going to evolve. You design a piece of plastic in CAD, when it comes out of the mold, plastic shrinks. So you need to work with people that have those really good factory floor engineers that have almost that intuition of saying, well, I know this is going to shrink a little bit here because it's in polypropylene or whatever it is. So I'm going to go ahead and make that modification before I even make a part. And that's stuff that you can't learn that in school, really. That's just the experience of people, the engineers that have been on that factory floor for a good part of their careers. Mm-hmm. So I'm rambling. I'll shut up. But I do that, or so my wife tells me.
That's all right. That was very interesting. Mark, moving into production, are you expecting the inventor to know what tooling to choose, how many cavities in a mold, things like that? Or are you going to help them pick that out?
Yeah, so not at all. We don't expect them to know anything. So we work with everyone, and I talk to everyone like I do my 10-year-old. So although my 10-year-old's smarter than me now, so I don't know if that works very well, but so we break it down, make the process very simple to understand. I do want to mention, I think we haven't brought this up yet, that and we've had this conversation with many of our inventors that we've worked with, is that you may not want to go into manufacturing. So there are opportunities to have an invention and then take on a licensing deal with a company and have them take the responsibility and the obligations to manufacture a product. There are certain products that we don't really get that involved in, one of them being medical equipment. We do not get too much involved in outdoor sports equipment a lot of times, or for instance, like a trampoline or a basketball hoop or something that you would ski on. There are regulations and there are factories out there that specialize in those particular manufacturable products, but we'll guide you through it. We'll help you find one that is going to work best for you. But licensing is a really unique approach where you could just make money off your idea, and you don't have to take on the bearer of and the weight of taking on the financial costs of manufacturing, which can be pretty expensive.
Mm-hmm, mm-hmm. Very good. Ray, final thoughts on manufacturing and bringing a prototype into manufacturing and issues for new inventors to consider.
The longer you can stay in the prototype phase, perhaps the more successful you'll be in manufacturing. I'm finding that, technology changes yearly. I have to go to conventions to find out, what's new and what we can do as designers to better simulate the manufacturing environment. A lot of these new 3D printers with SLS printing and, being able to simulate soft plastics, or even some sort of a dual shot, soft plastic, hard plastic, dual cavity type of property. I find that 3D printers can actually pretty accurately simulate a lot of those behaviors. And even beyond that, in softwares in CAD, you're actually able to simulate things like mold flow. Of course, you can check manufacturability and talking things like wall thickness or draft angles or something like that. And the computer can tell you whether or not something can be injection molded or whether or not it will stand the stresses that you're going to be asking the the product to stand up to. One of the things that we refer to a lot in computer simulation of a product is finite element. Finite element analysis is a hard word to say for me, but that's sort of like a digital stress testing of a product, so we can figure out if it's strong enough, or if we're designing something like a living hinge, we can actually do that in the computer. And then specifically for aerodynamic, hydrodynamic, or something that has some sort of fluid flow, we can use a CFD, which is a computational flow dynamics, which is really neat. You can actually figure out whether or not a computer is going to stay cool with the size of fan that you put on it, or how water is going to flow through a pipe. And it's sort of technology that I think came from perhaps animation or movie simulations, but a lot of that is moving into the product development process that allows us to make this thing digitally real, Mark, like you talked about in the virtual reality environment. And we can test it digitally. And from what I'm finding, things like weight and strength and even aerodynamics or hydrodynamics are well within range of being good enough for starting to get you closer to building that late stage prototype that Noah talked about. So a lot of that stuff can be done in the computer, I guess is what I'm saying.
Very good. Very good. Got it. Makes sense. So for anybody, inventor, they've got their product going through production. I don't like what's going on. I don't like, for whatever reason, the way things are going. Is that tooling mine? Can I move it? Are those blueprints mine? Can I move it, find somebody else and start going again? Are those considerations I need to be watching out for depending on who I'm working with?
Yes, definitely. So yeah, like Austin said earlier, everything that we do for our customer is theirs. So like you said, any specs, any prototypes, anything like that, if they do molds with us, that belongs to the customer. We obviously house it at our factory if we're using it for production, but if they want to move manufacturers and move, then it's theirs. We can have someone go out and inspect it and send them video and pictures and stuff of the molds, get it packaged up and ready for shipment. And then they just tell us where they want it shipped to. They would have to pay the shipping for the mold, but it's theirs. They can ship it to wherever they want. And we definitely encourage that they ask those questions if they're going to work with the manufacturer, because if they're going to pay for it, it should be yours.
It's all theirs. You can have it manufactured, moved to another facility in China. They can have it brought to the States. They can ask for it to be disposed. We've had that before, and then had video or photographic evidence for that. Touching on intellectual property as well, working with China, it can sound scary, but that's why it's important to work with a manufacturer directly. Our NDA does cover us here domestically as well as our plants and factories overseas. Again, we have the ownership in the factories. So the 30 plus years, we've had zero intellectual property and zero intellectual infringements. So that's a nice feather in our cap. But it's just make sure it's important who you work with. A lot of times when you get those infringement issues or those knockoffs, it's a lot of times you're dealing with an agent or a broker, a third party, so to speak. They have your specs and they send it to 10 different factories around the world. You know who's looking at them. You don't know what factories have seen them. And all they're trying to do is get the lowest cost so they can make the most money in their pocket and deliver you a crap product. Again, when you work with CMS or any other reputable manufacturer, you make sure you're working directly with them. And that's also what keeps the lid on a nice tight seal on the product, so to speak.
Yeah, because that NDA carries through the manufacturing phase, where these other situations, you might need separate agreements with the other.
Yeah, and in my experience, the knockoff problem happens. It's not your factory. Again, if you're working with a reputable factory, it's not your factory that causes that. It's you're on the market, you're successful. Someone just buys your product and they send it to a somewhat sleazy factory and say, "Hey, copy this." That's generally where you run into that, and it's kind of at that good problem to have stage. Usually, nobody's going to copy you until you're making plenty of money.
I mean, that you really took the words out of my mouth, Noah. Or the other partner of the company, John King, his favorite line is, "You should be so lucky," because nobody's going to knock off something that obviously is usually a new product or isn't really selling.
If your product is on the discount shelf at Big Lots, you're probably not being knocked off.
Correct. But we also have that issue where we had one of our products had that same issue. We were able to locate it. We found out during the importation that the documentation didn't have our owner's information or CMS. We have great relations with US Customs, as well as FDA, things like that. So everything that came into customs we're aware of. That product got notified, we were notified, that product was destroyed at the shipyard. And then not only that, our team in China was able to locate that factory and they were reprimanded accordingly. So, you know, you have that insurances as well.
Very good. Well, let's hope everybody on this call has that problem with the copycats and can get to that stage in their production, right? Boy, great discussion. Rachel, Austin, Noah, Mark, and Ray, thank you very much for the thoughtfulness. And I know we're going to be in the breakout session soon to answer questions.
Yes, awesome sauce. Thank you guys for that great, awesome panel discussion. Lord knows I've learned a lot during this this panel discussion about prototyping and manufacturing. I hope you guys learned a lot as well. So we are on time. So good job, guys. So at this moment, we are going to give you guys a quick 5-minute break. And during this break, we are going to put out a poll. So a poll question should pop up on your screen. It's just one quick question, just asking where you are in your process. Ivy is loading that poll question up now. And we'll return back here in 5 minutes. So I will see you guys at 4:05. And it looks like the poll is displayed. So if you could go ahead and answer that one question and let us know. Where are you in the process? Are you just getting started in ideation, ready for creation, or heading to the market? So answer that quick question, go grab you a quick snack, use the restroom, and we'll see you in 5 minutes. And thank you again to our panelists as well. You guys did an amazing job. Thanks, Ray, Noah, David, Austin, Rachel, Mark. We love you. Thank you. And we will see you guys in the breakout sessions.
Thank you.
All right, see you in 5.
The Chicago Inventors Organization welcomes the opportunity and challenge to convince donors and corporate funding entities that together we can create a Chicago that excels in the development of innovative products by underserved inventors. We are at a critical pivot point in America as to how we must create generational wealth to wipe out the poverty which exists among over 11 million Americans today. As a 501c3 nonprofit organization, we ask you to join us in our Creating Next Wave Inventor Entrepreneurs movement. challenge you to help us create new products and new businesses. Your sponsorships and donations will help us to enhance our Next Wave Inventors Academy and 3D Next Wave prototyping lab operations. Our Academy seminars focus on educating inventors on smart technology products, patents and trademarks, prototyping, marketing and pricing, pitching to buyers and investors, and negotiating contracts. Our prototyping lab provides hands-on support to independent inventors by using computer-assisted designs and 3D printed prototypes to make their products come alive. Your tax-deductible sponsorships and donations will help expand CIO resources to provide enhanced interactive working spaces for multi-generational inventors and purchase the necessary equipment to broadcast inventor classes and events to our network of innovators and the general public.
All right, all right, all right. Now, we are still on time, right? Okay, so now at this point of the conference, we are ready for our breakout sessions. And the way these breakout sessions will work, we actually have 3 separate rooms. One is legal, 2 is prototyping, and our 3rd room will be manufacturing. So for all of you guys that are participating in this in this conference, feel free to hop in and out of these breakout rooms. So if you want to hop in prototyping and get the information you need there, and maybe want to go into the legal breakout room, feel free to do so. You are not committed to stay in one room, so hop around as you see fit, and we will open the breakout rooms now. And you guys should see it on your screen. It should say more, and then you should have an icon that says breakout rooms, and then you guys can select which breakout rooms you want to go into, and Zoom will take you there. So feel free, click on that breakout room link and select your first breakout room, and have fun, guys. And for my panelists, no worries, we will assign you guys to your breakout rooms as well. All right. So we'll get started on those assignments now. I see some of you guys are selecting the rooms. Is it anyone that cannot find the room, the breakout room options? Let me know. All right, so let me get my panelists together. David, manufacturing, Kenny.
Tiffany.
Hey, love, how are you?
Okay.
Okay. Okay, you gotta, yep, click on that link that, it should be a link that pop on your screen for you to go into the breakout rooms, Ms. Collins. Yep, she got it. Yep. Calvin, where did he go? Okay.
This is Jay.
I think he just logging in.
Sorry, okay. Jay, let's put you somewhere. Jay, click on the link and you'll go into one of the waiting rooms. Thank you so much for joining. Okay.
You're so awesome. Hi, guys. What room did you guys want to pop into? Put it in the chat or unmute yourself and let me know.
Tiffany, can
Yes,
you hear
ma'am.
me?
Yes, ma'am.
Okay. I have my prototype. I put down heading to market.
Okay, but what breakout room did you want to go into? Manufacturing, prototyping, or legal?
I know what manufacturer I would like to use, CMS.
Okay, I'll put you in the manufacturing so you can talk to them. Hold on one second.
Wait, they already sent me the price. I know how much they're gonna charge me.
Okay.
Okay, so what would you suggest next?
I'm not for sure. It depends on what questions you have. Did you need to talk to Kenny about anything legal?
No, because I have my patent.
Okay, so those are our only three
Yes,
rooms,
I have
so-
everything that I need.
Okay, so you don't want to go into none of the three rooms?
No.
Okay, so it's up to you. I mean, we can put you in the waiting room, but these breakout sessions go until like 4:50, if I'm not mistaken. So, I mean, I didn't want you to just be idle.
Yeah, just be sitting, yes.
Yeah, so that's why I wanted to put you in one of those rooms.
Let's see,
Almost but I haven't filed a patent yet. I'm going to make.
okay, I'll go into manufacturing then.
Okay, no problem. Okay, it should be a little box that pop on your screen. Click on that box and it'll take you there. Perfect. Hi, sir. How are you? Ms. Finnessy, where did you want to go?
Manufacturing.
Manufacturing, okay. Hold on one second. Okay, you should also see something pop up on your screen and just click that button and it'll take you there. Okay, Mr. Bradley.
Manufacturing? The ones like when getting a paddock for my product and to get a non-disclosure form. I'm going to manufacturing.
Dennis Bradley, that means you want to go into legal? Is that him talking?
He said manufacturing. Mr. Bradley, I put him in manufacturing.
Oh, okay.
Yeah, he said manufacturing.
Crisscross breaking off some sauce.
Crisscross applesauce.
And Calvin keeps popping in. I was trying to catch him. Come on, man.
Hi, Mr. Bradley. I sent you to manufacturing. You should have saw a thing pop up. Just so you're in the manufacturing room. Can you hear me?
I ended up in.
I'm sorry.
Do we start recording this part? Are we recording? We're not recording in the breakout rooms, are we? No, right?
No, we're just recording out here, but I'm gonna.
This is one of the best. I think this is one of our best conferences that we've had to date. I think we've sort of nailed down the formula for what we want to do here and working with panelists who are like family to us. And mission accomplished is all I can say today. I think for those of you that aren't members, if you're an inventor, you want to be with the Chicago Inventors Organization. We're not a club, we're an organization. And if you go to our website, chicago-inventors.org, I'm sure you'll get a lot more information on us. You can also call us. Now that the COVID restrictions are down, we also are able to see people in our office, which is, we just moved into it the first of the year. And I think you can see from Calvin's, if you're looking at Calvin Flowers there, we got some artwork that was done by our artist in residence, Alejandro Alonso, that you'll find quite intriguing. But if you're a member, and if you're not a member, we are open to donations. We've just started our fundraising drive for 2022 fiscal year 2022-23, and we can certainly use help because the money's going to good use. Right now, it's going to be going to our prototyping lab, enhancing it, and also getting some broadcasting equipment so we can go out big time with, dig this now, a TV show for inventors on B-Spire, like Inspire TV, which is a YouTube channel that's out, run by a very dynamic young lady named Tracy Campbell. So that's something we're looking forward to, where inventors are going to be able to get their backstories, talk about their products. Panel experts like we had today will be able to come on, and it'll be recorded. And we've got a prototyping director, media specialist, Sean Bell, who does a great job. But again, Calvin, I'm going to turn it over to you, and just want to say to our esteemed panel, thank you, thank you, thank you.
Thank you.
Thank you.
All yours, Calvin. You got to unmute.
Thank you for having us.
First of all, I ditto that. I want to thank the panelists. You guys really share some really good information. And also to the inventors. I just want you guys to know that our whole goal is we want to help you guys get a product to market, start businesses around those products or inventions, and hire some folks out of the community and create some wealth. That's our whole mission. We want you guys to make money off your invention. So with that said, thanks for coming out. Everybody be safe, be well. And if you have any questions, don't hesitate to give me a call or give us a call at 312-850-4710. Thank you much, and we'll see y'all at the next conference, which is going to be our pitch contest. So get your elevator pitches together, all right?
Thank you, Tiffany O'Neill. Thank you, Ivy Ellis. It would not have happened without these two fantastic professionals. Thank you.
Well,
thank
everybody
you.
give them a hand. They did a great job.
Yeah.
There she goes.
Hey, there's Ivy. Oh my goodness gracious. This is WVON. Okay. Thank y'all.
All right, thanks, guys.
Thank you all.
God bless.
Talk soon.
Thank you. Everybody have a safe summer.
Yes.
Great day.
Wow. Oh, when did he say the pitching contest will be?